Hello, this is Casey Blaha, an MD PhD student at the University of Illinois at Chicago College of Medicine. This video is part of our Survivors Advising Scientists educational program, a bidirectional educational platform meant to connect our communities and increase scientific literacy and engagement. Our goal is to bring everyone to the table for scientific discussions related to cancer, science, and therapies. This is video number 5, Experimental Errors. In the previous modules, we've discussed the different components of an hypothesis and various experimental variables. Next, it is important to look at how the experimental results can be interpreted and different errors that can occur. What happens if researchers reject or accept the null hypothesis, but are wrong? There are two different types of errors that can occur. There is the type 1 error or type 2 error. A type 1 error is also known as a false positive. In the picture on the left, we see a physician telling a man that he is pregnant. This is clearly a false positive result or conclusion. We can also have a type 2 error, which is known as a false negative. In the picture on the right, we see a physician telling a clearly pregnant woman that she is not pregnant. This is an example of a false negative result or conclusion. Next, we will go through these different types of errors with more in-depth examples. Briefly, please recall this example of a hypothesis from the previous module number 1, Scientific Hypothesis. We will be using the same experimental design to talk about the different errors. First, we will talk about type 1 errors. In this experiment, the null hypothesis is that traditional mammograms are the status quo of early breast cancer detection. The alternative hypothesis is that a novel imaging technology called superscanner is able to detect more cases of cancer earlier than traditional mammography alone. When interpreting the results, a type 1 error occurred. Researchers claimed that the superscanner is more effective in diagnosing breast cancer than traditional mammograms. Researchers reject the null hypothesis. However, in reality, the superscanner was used by more senior radiologists compared to the radiologist who performed the traditional mammograms. Therefore, the superscanner was actually not more effective at imaging, leading to a type 1 error or false positive conclusion. Next, we have type 2 errors. Again, the null hypothesis is that traditional mammograms are the status quo of early breast cancer detection. The alternative hypothesis is that a novel imaging technology called superscanner is able to detect more cases of cancer earlier than traditional mammography alone. When interpreting the results this time, a type 2 error occurred. Researchers claimed that the superscanner was not more effective in diagnosing breast cancer than traditional mammograms. Researchers failed to reject the null hypothesis. However, in reality, the superscanner was not used properly. You can see in the top right corner that it was used backwards. So if used properly, the superscanner was actually more effective at imaging than traditional mammograms. The researchers had a false negative conclusion. Next, it is important to think about how type 1 and type 2 errors affect patients. Let's walk through another example and think about the side effects and consequences of each error. In this example, researchers wanted to test if a new vaccine will give patients immunity to the infection. The null hypothesis is the vaccine does not give immunity to the patient. The alternative hypothesis is the vaccine will give immunity to the patient. First, you can have a type 1 error or false positive. In this case, researchers conclude the patient is immune to infection after the vaccine, but in reality, they're still actually vulnerable. You can also have a type 2 error or false negative. Researchers conclude the patient is not immune to the infection after the vaccine, but in reality, they're actually immune. Think about how each result and error might make you feel and act with different consequences. For instance, type 1 errors or false positives might give the patient a false sense of security of immunity and change the way they react to a situation, change their behaviors such as wearing a mask and social distancing. Next, we will discuss highly specific or sensitive tests. First, we will discuss highly specific tests. Specificity is a proportion of patients without the disease that receive a negative test and are true negatives. A highly specific test means that there are very few false positives or type 1 errors. Below is an example of this. Hospital A uses tests that say 100% of men are not pregnant. Therefore, there are few false positives. Hospital A's test is highly specific. All of the men are told they're not pregnant. Hospital B, on the other hand, uses tests that say 50% of men are not pregnant, leaving the other half of male patients very confused. Therefore, there are many false positives. Hospital B's test is not specific. Half the men are told they are incorrectly pregnant. Next, we have highly sensitive tests. Sensitivity is a proportion of patients with the disease that receive a positive test or true positive results. A highly sensitive test means that there are very few false negatives or type 2 errors. Below is an example of this. Hospital A accurately tells all pregnant women that they are pregnant without telling any of the pregnant women that they are not pregnant. Therefore, there are few false negatives. Hospital A's test is highly sensitive. In this picture, 100% of pregnant women are told they are pregnant. Hospital B, on the other hand, tells 50% of pregnant women that they are pregnant, while telling the other 50% of pregnant women that they are not pregnant. Therefore, there are many false negatives. Hospital B's test is not sensitive. This is depicted in the picture where half of the time pregnant women are told they are not pregnant. Thus far, we've discussed the different types of experimental errors in sensitivity and specificity tests. So when evaluating experimental tests, you can ask these questions below. Are the results highly specific with few false positives? Are the results highly sensitive with few false negatives? Please remember not to get lost in the math. If numbers look complicated, ask the researchers to clarify the sensitivity and specificity without talking about the details. This is the end of Module 5. Now the presenters would like to thank Dr. Kitayeski and the administrative staff of the University of Illinois Cancer Center for their support in this effort. Additionally, we'd like to give a special thank you to all the cancer patient advocates who provided feedback during the development of these modules. We'd also like to thank you for reviewing this module, and we invite you to send any feedback on this module or suggestions for future content to. Please feel free to move on to the next module, number 6, on statistical significance. Thanks again.